two slits, and these are separated by a distance of 1 millimeter. There is a screen, and the screen slit distance is 1 meter, and there is a source, and let's say the source has a wavelength 500 nanometer. Then you know the storylining. Source से waves निकलेंगे, and when the waves pass through the small slits, they would behave as independent sources, and at a given point anywhere, one wave and another wave both are coherent, they meet, and that will form interference. और question शुरू करने से पहले you will get the condition for constructive interference. Delta x is plus minus n lambda, and phase difference delta phi, or phi simply, is plus minus 2n pi, and in this situation n begins from 0. Let me make you clear with the terminology that we use. n को अगर 0 लेंगे, path difference 0, phase difference is 0. It is equivalent to say path difference 0 कहना और phase difference 0 कहना, it's the same thing. और अगर n को 1 लिखेंगे, path difference will be plus minus lambda, and the phase difference will be plus minus 2 pi. Notice, it is equivalent to say a path difference of plus minus lambda is equivalent to say a phase difference of plus minus 2 pi. Similarly, next you will get is plus minus 2 lambda, and this will be plus minus 4 pi. ये था condition constructive interference के लिए. अब destructive interference की बात करते हैं. Delta x is plus minus 2n minus of 1 lambda by 2, and phase difference is plus minus 2n minus 1 pi. और यहां हम n को 1 से बिगिन करते हैं. तो जब हम n को 1 रखेंगे, you'll get plus minus lambda by 2, and this will be plus minus pi. n को अगर 2 रखेंगे, तो you'll get this as plus minus 3 lambda by 2 and plus minus 3 pi. Now let's concentrate only on the path difference, because saying path difference and saying phase difference is equivalent. आप देख सकते हो, this path difference is 0, और इसको कहते हैं central bright fringe. तो सेंट्रल ब्राइट फ्रिंज का मतलब यह है दैट पॉइंट जहां दो इंटरफेयरिंग वेव्स के पाथ डिफरेंस है 0. अगर पाथ डिफरेंस प्लस माइनस लैम्डा है, तो उस पॉइंट को हम कहते हैं फर्स्ट ब्राइट फ्रिंज. सो इफ द पाथ डिफरेंस इज प्लस माइनस 2 lambda, we call it second bright fringe. So you should be very comfortable with the language. If the question says locate the third bright fringe, यानी वो पॉइंट जहां पाथ डिफरेंस है प्लस माइनस 3 lambda, और ये है फर्स्ट डार्क फ्रिंज, क्योंकि ये कंडीशन ऑफ डिस्ट्रक्टिव है, और ये है सेकंड डार्क फ्रिंज. इसीलिए इसको हम n को 1 से बिगिन करते हैं. सो दैट यू प्लेस n एज 1 फर्स्ट डार्क फ्रिंज, n एज 2 सेकंड डार्क फ्रिंज. इस पे n को 0 सेंट्रल ब्राइट फ्रिंज, फर्स्ट ब्राइट फ्रिंज, second bright fringe, depending on the value of n. So if the question would say me sixth bright, I'll place n equals to 6. Yeah, if the question says sixth dark, I'll place n equals to 6 here. So let's come to this point. There is a source 500 nanometer separation between the slit. Generally it's represented by d, and this is represented by capital D. And let's see the question. The question is, find the location of second bright fringe. So it would be something like this. First, these two waves are coming here, and at any given point, not necessarily in front of the slit, any given point, हमें एक ऐसे पॉइंट ढूंढना है जहां पर लोअर वेव और अपर वेव के बीच के नेट पाथ डिफरेंस second bright fringe यानी n equals to 2, so path difference has to be 2 lambda. In other words, the question has been reduced to search a point where the net path difference is plus minus 2 lambda. Plus would be for the upper and minus would be for the lower one. So we have to search this point. So the whole game plan has now reduced to search that point where the path difference is 2 lambda. This side, there is no path difference. So the only path difference is here. So we'll use the same technique now. Let me draw the inner one now. So here is that point. और आप देख सकते हो ये डिस्टेंस है 1 मीटर और ये डिस्टेंस है 1 मिलीमीटर. तो अब मैं ये कह सकता हूं दोनों के बीच के जो पाथ डिफरेंस है दैट कैन बी फाउंड बाय परपेंडिकुलर. तो दिस इज द नेट पाथ डिफरेंस डेल्टा एक्स, एंड लेट मी कॉल दिस पॉइंट एज थीटा. You could easily see this distance is small d, and if this is theta, this angle would be theta. So theta delta x small d, delta x equals to d sine theta. So next time in the calculation of YDSC, I'll not be elaborating this point. हम स्ट्रेट वे दो वेव्स को दिखाएंगे एंड अंडर द कंडीशन कैपिटल D is very much greater than small d, पाथ डिफरेंस को परपेंडिकुलर से दिखा सकते. सो दिस इज द पाथ डिफरेंस. अब हमें जो चाहिए रिक्वायर्ड d sin theta equals to 2 lambda. I'm not writing the negative one क्योंकि सेंटर से अबव लोअर पाथ इज लॉन्गर, सेंटर से ठीक बिलो अपर पाथ वुड बी लॉन्गर, सो दैट सिग्निफाइज द नेगेटिव वन. एंड साइन थीटा इक्वल्स टू 2 lambda by d. We'll put that value. बट इस सिचुएशन में आप नोट कर सकते लैम्डा का जो वैल्यू है वो नैनोमीटर में 10 raised to the power minus 9, and small d is in millimeter. Yani this time sin theta is very small and this angle is small. What I was stressing in the initial geometry, capital D very much greater than small d does not mean theta is small. This means path difference can be calculated by perpendicular. बट क्योंकि वैल्यू लैम्डा के कंपैरिजन में देखा जा रहा था और साइन थीटा का वैल्यू you could see now you require the second maxima, so 2 lambda, and sin theta is small only because lambda is very much less than small d. But the question had demanded to find the distance from O. So let me call this point as y. The same figure, this angle was taken as theta, and there is another small valid approximation क्योंकि capital D is very much greater than small d. This line and this line are almost parallel. In other words, this angle would also be theta. तो अब आप ये ट्रायंगल में देख सकते tan theta equals to y by capital D. And I know theta is very small. So under this approximation, I can put sin theta equals to tan theta. यानी y by capital D की जो वैल्यू है वो बनेगी 2 lambda by small d and y equals to d by small d into 2 lambda. Now placing the respective value, you would get the point of second bright fringe. If the question would ask, find the location of third dark. So let's see. Let me again begin. From here, there is no path difference. Whatever is the path difference, that would be inside. और path difference कितना चाहिए हमें? Third dark. So n equals to 3. So that will be 5 lambda by 2. In other words, 2.5 lambda. तो हमें एक ऐसे पॉइंट ढूंढनी है जहां पाथ डिफरेंस है 2.5 लैम्डा. अब यह अप्रोक्सीमेशन फिर भी वैलिड है. अब 2 लैम्डा के बजाय विल राइट एज 2.5 लैम्डा क्योंकि फर्स्ट वाज फॉर द सेकंड ब्राइट, नाउ इट्स फॉर द थर्ड डार्क एंड दिस वुड नाउ बी 2.5 लैम्डा. और अभी भी sin theta is very small क्योंकि this is in nano, this is in millimeter. Then tan theta y by d, because theta is small, so by the same calculation, and now y by d would be 2.5 lambda by small d, and the whole thing comes here. Means at that location of y, you will find a dark fringe, and that's called as the third dark fringe. So this numerical now will make you very comfortable in order to derive a general expression for YDSE.